Hello one and all, and welcome to the Mad Magic Show, and to the concept of a hole in a graph. Here I have a graph. Let's go over this graph a little bit. So this is one portion of the graph, and notice that over here, as you can see, is a hole. Let's go to the expression. What we have then is the following. X squared plus 3x divided by x plus 3 over x plus 2. So in this one, we're just focusing on the holes. So I observed that in the bottom, x plus 3 and then x plus 2 are already in factored form, but x squared plus 3x that's not in factored form. For that reason, I have to factor. And I do that by, in the numerator, taking x out. So because I have x squared, that comes out as x by itself, and then because I have 3x, I pull the x out, so it becomes just x on the outside. So I end up with x multiplying x plus 3, and then in the bottom I have x plus 3 times x plus 2. Now when you look at this expression, I hope you observe that the x plus 3 is in the top, and it's also in the bottom as x plus 3. So when you have a common factor, the opposite of that value is where the hole occurs. So the opposite of positive 3, that's what I mean. The opposite of positive 3 is negative 3. That tells you that's where the hole occurs in terms of the x-axis. And we can see that over here, because over here you see it says negative 3 in this position. And then as a consequence, on the graph itself, as you can see, there's a hole that appears there, okay? But let's see why. I don't want to just tell you that there's a hole because the x plus 3 in the top and bottom cancel off. Let's actually try to see what happens when you plug negative 3 into the function. That could be a bit interesting. So let's go through that process. So I am replacing x with negative 3. So this is negative 3, and then also negative 3 down below. So everywhere I see x, I replace it with negative 3. Okay, next stage, I simplify a little bit. So negative 3 plus 3 is 0 on the top, and then on the bottom, negative 3 plus 3 is also 0. So I end up with 0 on the top, and then multiplying negative 3, and 0 on the bottom, multiplying negative 1. Now, as you can imagine, anything multiplied by 0 is 0. So at the last step, this is going to tell me 0 over 0. In other words, I have an undefined quantity, okay? So that's the result of trying to plug in x equals negative 3 into the function. You end up with d and e, does not exist. Division by 0, in this case very specifically 0 divided by 0. Let's make a picture of this. So the picture basically kind of suggests that you take your negative 3, you stick it into the function, and out comes a hole. In other words, the hole that we see is a way of representing graphically this quantity 0 divided by 0. Now, that's just the hole at x equals negative 3 itself. What happens though around the hole is just as important. Let's take a look at what I mean here. So imagine that I plug a value into the function that is slightly to the right or to the left of the negative 3. So in other words, imagine that here I choose a value slightly to the right of negative 3. So for example, I'm going to indicate that with this blue arrow. So say that's a value, say, of negative 2.9. That's a value slightly to the right of the negative 3. So when I do that, let's see what I get as the output. So I have negative 2.9 as going in for x. Everywhere I see it in the expression that represents the function. So I have negative 2.9 multiplying negative 2.9 plus 3 divided by negative 2.9 plus 3 multiplying negative 2.9 plus 2. Okay. When I work this out, and even before then, I can observe something that clearly the negative 2.9 plus 3 and the negative 2.9 plus 3 in the bottom, because there's one in the top and one in the bottom, it's the same number really, you can cancel that off, correct? But we're not doing that just to be kind of not skip any steps or make things disappear. So when I work out the value here, that's going to give me 3.22. In other words, I can indicate that by drawing basically like a little line that you kind of see above me there that indicates that that's the y coordinate that's output. So when negative 2.9 goes into the function, 3.22 is put out along the y-axis. Now that value there is pretty close to the 3, isn't it? Let's take a look. What else happens around the hole on the graph? So you do that by now grabbing a value slightly to the left of the hole. So maybe like negative 3.1. Now you should know that there's nothing special about choosing negative 2.9 and the negative 3.1. Just choose a value to the right and one to the left. Hopefully not too far away, that's all, okay? And now take a look. So imagine I grab actually negative 3.1. And so go through that calculation. So I'm indicating that here with the red arrow to indicate I'm grabbing negative 3.1, and it's going to go basically bounce off the curve over to the y-axis. Okay? It's kind of how you imagine producing a function output using little arrows. Now the end number itself will look like this. So I'm replacing x with negative 3.1, and then I have negative 3.1 plus 3, and the bottom negative 3.1 plus 3. also, and then negative 3.1 plus 2. So everywhere I see x, I replace it with negative 3.1. When I work this out, for example, on my calculator, that's going to give me this value 2.82. That's this value right there, 2.82. And you can indicate that by, for example, drawing an arrow. So what do we observe here? What's the essential concept? Let's observe something important, in other words. Take a look. What I see is that while there's a hole when the negative 3 itself goes in, and there's a hole present because that gives you 0 over 0, around the hole, the graph is very stable. What I mean by stable is the following, that these outputs that you see over here, 3.22 and 2.82, as you can see, are very close together. They're not wildly different. It's not like you have 90 on one side and negative 500 on the other side, okay? And that's a common feature of holes. That's how you can identify a hole, for example, in a rational function, so to speak. So you would do what I did here. You would take your x squared plus 3x over x plus 3 over x plus 2. You would factor that. That would give you this x multiplying x plus 3 over x plus 3 over x plus 2. You would basically then proceed to cancel off the x plus 3 because that's a repeating quantity in the top and bottom. But the consequence is that the opposite of that, a negative 3. That's where the hole would occur, just the way I showed you here, because that would give you the 0 over 0 part. Well, that is it for me. Thank you so much for watching. Please leave a like and subscribe. I hope this has been helpful and insightful for you.